So Terence, recording is on.
Yeah, I've begun the recording. Gerald, Isaac, Hilda, you can confirm it's recording?
Yes, it's recording.
Okay, carry on, Major.
Okay, so good morning and welcome to today's lesson. And
Good
today we'll
morning.
be tackling high availability in regards to how we build infrastructure and deployments in AWS. So without further ado, let's get started. I know by now when you are doing this, you might have come how we can make your architecture highly available or designed for failure. So let's look into deep some of the strategy that can be involved and all the strategies that can make use of. So objective of this unit will be highly available solution architecture within AWS, and how can you be able to design for failure and design for high availability for tolerance while still balancing cost efficiency, because there normally seems to be a fight between costs and high availability. The more you make your architecture highly available is the more cost you incur, and you need to find a balance in between. As you remember, some of the pillars of the architecture framework, despite performance efficiency and resilient, you still need to balance cost optimization. So there's no prescription on this slide, but I know you are now have some knowledge regarding AWS. So design for failure at the global level. So when you design your structure, you need to assume that everything fails. And there is a quote, remember, from Dr. Vanna, the CTO and VP, says during one of their events, you need to design everything fails all the time. So that in this means that your mindset need to understand what will happen at some point, failure that is it will happen, and prepare to ensure to recover it. So it's not about matter of if, but now when. So you should not focus on preventing it, but you should focus on how you can navigate around it. So your objective will be to design by making system resilient to failure, ensure recovery as quick and effective. So system will fail, but when they do, what are some of their mechanisms that you have put in place to make sure that is not impacting your application downtime, what we call RPO and RTO. So some of the things that you can put in place, one of the basic one, we know that is backup. But now it depends on how long should your RTO or what amount of data should you need to recover in RPO. So this is like a simple application. Maybe let's say you are deploying in AWS and you have your application in the farmost left. You can see it is like a website in a machine. And this website is querying data in a backend service, would be a database. So you should focus your mind in trying to find a question. What will happen if this DB has an issue? And one of the things that I know we'll cover a bit more later, but just highlighting on them, you can make your DB highly available using, if you are using RDS, you can make things like RDS multi-AZ deployment. So in the previous slide, we learned that now this is like the architecture, and regarding it now, that was very high level. Now we can see how we can deploy. Maybe you have a region, US East 1, and this is a deployment in a single availability zone. So you have the VPC there, you have your internet gateway. Now you have your web server that is running on an EC2 instance, and you have your RDS that is running in a private subnet, which is the recommended way of deploying a two-tier application. Public subnet, you have the web facing, internet facing, and then you have the database in internal facing. So as you can see, if you are if you are keen enough, you can be able to see, despite being a two-tier application, this whole application has been deployed in a single availability zone. So the question that we'll be asking ourselves, what if this availability zone, there is an outage? So you see all your application will be down, you will not be able to serve the traffic. So both the front end and the back end will be down, completely down. And that's why the next slide highlights on. So in terms of failure. So when failure occurs, since it's a single AZ, you know what happened. Your infrastructure, your website, and both your backend, your DB in your backend will not be able to serve traffic. And also your website will be down. So this will run into a completely outage. Hence, what you can conclude in this architecture that you have not taken into account design for failure, because if you take into account design for failure is whereby design for failure that if such a thing happen, your business operation should not be impacted, should be able to serve traffic or your normal operations. So I think by now you are quite aware with AWS global infrastructure, where however the global infrastructure is made up of regions, and regions make up availability zone, and now they have availability zone host individual data centers, which are independent from independent power supply, independent network, but they are linked together as is in a region using high latency speeds, internet speeds, so that they be able to communicate with each other. Hence, some of the way that you can implement redundancy to counter what we experienced in the previous slide, whereby a single AZ can go down, is you can make use of AWS global infrastructure, things like multi-AZ and regions. So AZ, what are AZ? This diagram is just like a description of an availability zone. So these are just physical data centers. They host physical data center of AWS global infrastructure. So there is whereby the services like compute, storage, network, and database will be hosted. So when you have multiple availability zone come together to make up a region, as I said previously, that we have region at the highest level, and then inside the region we'll have availability zones, and then availability zone now hosts the data center, in which now hold the actual AWS services that you are making use of, you are consuming, you as the user or a customer. So previously our deployment was in single AZ. So you see disaster happen, you cannot prevent from it. So what about if it happens? If you have deployed in a multi-AZ environment where you have catered for design for failure, you can see the topmost AZ here goes down, that is grayed out in like reddish shade of red. If it goes down, these other availability zones can be able to counter out the impact that is created by the AZ that is down. So if your application is run in two, you can see that maybe the one of the down availability zones, the two below it, will be able to serve traffic for your users. So regions, as we have said, now region will make up of 2 to 3, even up to 6 availability zones, because initially it was.
So what will you drive that? No, I didn't. I was drunk.
Pardon? Is that a question? Okay, let's move on.
I don't think so. Can proceed.
Yeah, please mute yourselves. So now AWS regions, as I was saying before interruption, sorry, made up of these availability zones. So you can have multiple. Initially there were like 2 to 3, but nowadays I see that some of the region can even have up to 6 availability zones. But for design for failure, it is recommended to implement 2 to 3 availability zone, because the more availability zone you're making use of is the more cost that will incur. So region are isolated, located globally. Most of the region are located in the US, and I think this is because even AWS, I think last time I checked, they had over 4 million customers. And out of these 4 million customers, I think around 50% are located in the US. And you see AWS will make this region where their customers are. And as a company that emanates from the US, you expect to start building region in the US but they have region even. For example, in Africa, they have one in South Africa, and also Europe and Asia. So one region can see here, like the one in below in South America, maybe Brazil, it will have now multiple AZ in it. So every region can have multiple availability zone. So still region and the physical data center and availability zone that are in between. So remember initially our architecture, we had designed in a single AZ, whereby the website, it is in public facing subnet running in an EC2 instance, and then we have our database in private subnet. And if you are keen enough, you remember we said, for this kind of deployment is not good and you have not catered for design for failure. As if anything happened in an availability zone, if a disaster happened, you will see that the full stack of your application, the whole stack of your application will be down. The front part of it, the front-facing, web-facing application, and also the DB that communicates with your website will not be able to be serving traffic. So what can we do to mitigate such an outage? So that's why we can implement a multi-AZ deployment. So it's the same infrastructure whereby your application is still in the public facing subnet and the database in the private facing, internal facing, subnet. So the application is running into availability zone. Still the same region. So we have AZUST1. So that is on the left side of this slide on the diagram. And AZUS is 1B. So availability 1B and 1A both run a copy of your application. And then they're linked together because they need to communicate. Otherwise, if anything goes down, how can be user migrated now to be served traffic from the application that is running in the second availability zone? So one way we can do this for the front facing, I think you are quite aware right now when you do networking about application load balancer, can be able to be distributing traffic between your application running your targets. So the targets can be in the same availability zone, but mostly used for balancing those targets in different availability zone. Because if you just deploy EC2 instances, scalable in a single availability zone, we're able to cater for scalability, but you'll not cater for highly available, designed for failure. That's why you are normally recommended use application load balancer. And if you have more than one, make sure you have instances running in the two availability zone. So as you can see here, web server running in availability zone 1A, and also we have our web server running in availability zone 1B. And on the backend, RDS, RDS by default is somehow a managed service, so it caters for it. So you can just select multi-AZ deployment with synchronous replication. So you can have the DB running in the primary availability zone. So we normally call it the primary. So it will be the one now serving traffic. And then you'll have like RDS standby in the second availability zone. So if the outage happens as initially like availability zone 1A is affected, still traffic will be served using resources in the availability zone 1B. Application load balancer, as I say, you can make use of Elastic Load Balancer, auto scaling, and support workload. Remember, LB can support even advanced routing and some more feature rather than just balancing traffic, but it normally balances traffic at the application layer. So you'll have your target EC2 instances. You can have multiple targets, mostly in a two availability zone, and then when you register them, it will be able to distribute traffic. So still the architecture diagram that we are seeing that has been implemented to cater for failure, designed for failure, that is that the copy of your application stack is running in two availability zone. One standby, the other one like a backup to the DB side of things, and the application can run as active. Yeah, so if anything happens, you can see now, initially, when the availability zone 1 was highlighted red, that something has happened, there's an outage. the application was not be able to now serve traffic. But this time round, we are serving traffic in 2 availability zones. So when such an instance happen, you have designed a well-architected framework whereby you have cut off for such an event. So such an event happen, still traffic will be served using the second availability zone. So application load balancer, normally what happens, normally sends these health checks to see if your instance is still up and running. So if it found that the instance in availability zone 1A is not up, what we'll do, will now be directing all the traffic to the instance that is in availability zone 1B. Now the primary is down. So what will happen is duplication will happen. So also this one, the standby will be able to promote it to now the primary, and now be serving traffic rather than using the primary that is in an outage, have an availability zone that is experiencing an outage. Yeah, so that's what I was explaining. So you have now the web server in availability zone 1A is not able not to serve more traffic, and also the DB, since they are in the same availability zone. So now the C2 instance in availability zone 1B will be the one that the application load balancer routing traffic to. Application load balancer will stop routing traffic to availability zone to the web server running in EC2 instance in 1A, and now serve only traffic to the EC2 instance that is running in 1B that is hosting your web server. And the standby, as I say, will be able to be promoted to now the primary. Another thing that can be done in this architecture, you can also add auto-scaling group. So the running in availability zone serve as a sort of redundancy. But remember, if your application was designed to be, your users, the traffic was designed to be handled by 2 EC2 instance, you have now some sort of traffic routed to 1 EC2 instance. So at some instance, though rarely, your EC2 instance, the 1 EC2 instance that is running in 1B can be overwhelmed with the traffic. So what can you do to implement now scalability and also not experience an outage in terms of denial of service due to too much traffic sent to 1 EC2 instance? You can enable auto-scaling group. So auto-scaling group will be able, as you know from your compute point of view, will be able to launch EC2 instances based on an MI when such instances become faulty or an availability zone. So auto-scaling group can be able now to return either to launch. If the instance is the one that had an issue, it can be able to launch another instance and see. If the all availability zone was the one that was experiencing, can be able to launch an instance now in 1B and keep on serving traffic. So you can see here. So if it is now just the instance that was now experiencing an outage in the first availability zone 1A, auto-scaling group can come in handy and launch another instance and terminate the faulty instance. So using such architecture, you can be able to continuously serving traffic and experience very low outage for your users. Your website will be able to be up and running and no outages as you are implementing an architecture that has been well architected and catered for design for failure. Making use of now the regions, availabilities on that are in a region, AWS region. So what happens, we can see now using availability zone, we have been able to cater for outage in an availability zone. So what about if you have an outage in an entire region, like US East 1? US East 1, you can see web server in availability zone 1A is down. Also availability zone 1B is down. So how can you also enable highly available architecture in such a scenario? So what you can see is that now, apart from using availability zone, you can make use of regions. So you see availability zones are located inside one geographical location, but region are located distantly, maybe one even in one very long distances. Even you can make use of one region in one continent, another region in another continent. So in case such a thing happen, can be able to also ensure that your application can be able to continue running normal day operations. So as previous slides, as we have learned, we can also experience, let's just go a bit back. So we had kata for a failure, an outage in a single availability zone. But as I was saying that availability zone failure can also be experienced, and when the experience you can make up of region AWS regions. And it's good to know that despite that, also region can experience an outage, the whole region, but it's very rare to occur. So current limitation multi-AZ does not provide enough flexibility to recover from a region failure. So for such an instance, multi-AZ will not be able to help us. And the consideration that I was saying that we can make use of is considering multi-region design. And this is to cater for things like RTO and RPO. So the recovery time objective and also recovery point in time. So remember, initially I said, when you are designing your application, make it highly available. There is some like constant fight between cost and making your application highly available. So if you're running application in a single availability zone, add another one, so you can see the cost will double because you are running the same instance in another region, in another availability zone. And the same will apply when you use multi-region. Carries more cost, management, and design features, may need to duplicate a lot of your resources, needs to maintain data synchronization and data transfer, needs to deal with also potential latency issues. Why need to duplicate a lot of your resources? So you see, in a region, there are some of the services which are regional based. One of them is like an S3 or an EFS. So you can just have EC2 instances that are running in two availability zones, but they can be able to make use of the same region, a regional service. But when now you are making use of regions, you cannot use now the regional service. You need to have an EFS or an S3 bucket in one region and another S3 bucket or an EFS in the other region. That's why you see you may need to duplicate a lot of your resources, not as though you are making use of multi-AZ. So RTO and RPO, so recovery time objective. This deals with the time in which you need to recover from a failure. And also RPO, this is the amount of data loss that you are willing to tolerate. So when considering multi-region, shorter RTO and PO may require a multi-region design. And longer RTO and RPO may be fine with a Z design. So it depends on your SLM. So if you have shorter RTO and PO, so it means your application should be highly available, so you can make use of multi-region. But you have a longer RTO and RPO, so it means your business can withstand interruption. So you can just make use of multi-AZ deployment as we were discussing in availability zone 1A and availability zone 1B. So if website is down, can be able to be up, but since it will cost extra money for you to maintain a highly available architecture, it can experience an outage in a single availability zone, and the rest can be able to cater for you. And this is like a multi-region. You can see here, these are let me try to annotate. So this is like one region. So let's say region 1. So inside a region, you have AZ availability zones, which now host the data center, AZ1. And then you can have AZ2. And then you can have also AZ3. So the pattern you see is keep on repeating. So this one you have now region 2. And then you can have region 3. And all the region have availability zone, and availability zones have data center that is hosted in them. So you see, with the running your application in a single region using multi-AZ, you are able to make use of application load balancer to route traffic. Remember, these duplicates environments need to be able to communicate with each other. In case of outage, there should be very low RTO and RPO. But now when you come to just a minute, this annotation tool, let me just, yeah. Now when you come to region, you can see application load balancer can only balance traffic in a single region because it's a regional service. But when you are doing multi-region deployment, now you need to make use of Route 53. Now Route 53, because it's a global service, can be able to route traffic between regions. And then Route 53 can make use of Amazon CloudFront. As you all remember, CloudFront is also a global service. And now it can be inside now your regions. If you have also implemented multi-AZ, now you can have your application load balancer and auto scaling group. Now can be able, so you have multi-AZ, multi-region deployments. As you can see, I told you like yes, I noted it again. So I was saying that for this is a single region that is implementing multi-AZ. And as you can see, you are using just one LB. But now you have duplicate web server and web server. But when you go to another region, multi-region, you have a complete duplicate whereby you have still application load balancer, you still have web server in one availability zone, another web server in availability zone. That's why there was a point there we spoke about more duplicate resources. So for regional service, when you're doing multi-AZ, you can be able to use things like ALB, S3, EFS, those are regional. You can be able now to just mount EFS and the two instances. Let's say EFS, instead of using ABS, can use of EFS, and then they can make use of this. If you have data that is stored, maybe the EC2 instance, time to time, they save data to the S3 bucket, so you can just have one S3 bucket. But when you come here, this S3 bucket cannot be used inside here because S3 bucket is a regional service and cannot be accessible in another region. So you need to launch another S3 bucket if you are making use of S3 bucket. If you're also making use of EFS, you now need also to create another EFS volume. And now also an application load balancer to route traffic between now the two availability zones that run your EC2 instance. Yeah, my limitations. So with multi-region deployment, we will be making use of data replication. So to cater for recovery time objective, RTO, and also RPO, and also snapshots and restore. So snapshot will be taken, and then the snapshot can be able to use now to restore your deployment in another region when there is an outage. Still, cost can be an issue. I think you had. So despite now incur you a lot of costs, when you do this, can have a lot of benefit. As you see, architecture can be highly available, low outage in your deployment, so less business disruption and more customer satisfaction, and can not lead to customer truncation, whereby customer leaving your service because they experience outage and can affect now your business profits. So still, I think we had talk about this architecture whereby you have multi-region deployment with O53 and Amazon CloudFront that is make use of. So RTO, RPO, snapshot, and restore. So we can have our RDS primary. You can have of the AWS Lambda, CloudWatch to monitor, and then event bridge. So RDS, and then a snapshot is taken, and then maybe this snapshot is copied in another region. So that in case of anything now, you can be able to use the snapshot to restore your database. So that is like the life cycle. And also you can make things like AWS database migration service. You can be able to migrate your database from one region to another, normally also used for data migration from on-premise to cloud. Okay, this diagram also data replication, whereby RTO, cut off RTO and RPO, making use of snapshot, and you can be restored in case of an outage. So RDS primary, you can have RDS primary, and then you can have now a standby. And you know that if anything happen in case of an issue with the primary database, the standby database can be able to be promoted to a primary database. So I think we are done with our first part, unless there is question regarding what we have discussed, before we journey to disaster recovery definitions. No questions? Silence means maybe no question, you can move on. Okay, so let's look some of the terminologies in terms of disaster recovery. Before we discuss how we can implement it, it's good to get used grasp of what they mean and the implications. So we have recovery time objective is one of the disaster recovery strategy, and also RPO. So recovery time objective, this can be defined as the maximum acceptable downtime for a service before it becomes damaging to the business, while RPO is the maximum amount of data loss in the event of disaster. So RPO deals with what amount of data are you willing to lose, and RTO is about how much of time or business disruption is your SLA permit you for your deployments. But we should focus on maximizing both the RTO and RPO. Disaster can be, and disaster that can cause to interrupt with this RPO and RTO can include like earthquakes, floods, and cause unauthorized access to malicious attacks. So disaster signifies a catastrophic event having huge impact on your resources that we discussed. Earthquake can be anything, even can be malicious. Malicious hacker needs to disrupt your service. So earthquakes impacting availability of a global infrastructure and authorized access, resulting in malicious activity against your resources, can be flooding or fire. Remember the recently happened fire in California where houses were burned, damage to AWS data centers. So can still happen. Now, as we are defining RPO and RTO, it's very good to know that the distinction between the two terms when you need to make your application available and cater for disaster recovery. So RTO is the maximum amount of time in which the service can remain unavailable before it is damaging to the business. So some business can afford hours, some even minutes can be very catastrophic, while RPO is the maximum amount of time in which data could be lost for a service. So recovery point, objective, time data loss, while RTO deals with downtime. So how much data loss in terms of RPO, when you deal with RPO, how much data loss are you willing now to lose in terms of an outage? While RTO is how much downtime can you able to, your business can be able to tolerate interruptions. So RPO will deal with acceptable data loss. It tells you how quickly you need to recover and resume normal operation. And one example can be if your RPO is 1 hour, this means that you can't afford to lose up to 1 hour of data. Any data created or modified within the last hour will be lost if disaster occurs. So RPOs focus, of course, on data loss. On the other hand, RTO tells you how quickly you need to recover and resume normal operation. So this is in the point of now you designing for failure, what you need to be done. So RTO focus on how fast to recover. Example, if your RTO is 4 hours, this means that your business can tolerate up to 4 hours of downtime. After that, the service must be restored and it will start focus on significant business interruptions. So in order to counter for outages and minimizes the RPO and RTO, we can make use of some strategies whereby you can have the backup and restore. These are disaster recovery strategies, just to note. So you can have backup and restore, you can have pilot light, you can have warm standby, and you can have multi-site active. So from, so as you go down, costs increases, but at the same time, RTO and RPO also decreases. So, oh, no, this is not it. Okay, cost increases, sorry. So we'll have cost increases as you move down from these strategies. At the same time, RPO and RTO decreases. And RTO and RPO decreasing, which means your application is highly available, will experience less business interruptions, but it comes at a cost. So you need to note. So you need to ask your question when you're deploying, because some businesses can withstand interruption. There is no need to incur such huge cost while implementing highly available solution. And at the end, the costs of running your business in cloud start being impacting and you start now making losses. So you need to find a balance. And that's why there are all these strategies. And all these strategies is not like they are bad. As long as you have a strategy that suits to your SLA, I think you are good to go. So let's start at the first one, backup and restore as a disaster recovery strategy. So this provides the highest RTO and RPO. Typically provide RTO in 24 hours or less. RPO can generally be measured in hours. So you see, as the highest, as I said in the previous diagram, as you go down, RPO and RTO decreases, but cost do what? Increases. So backing up to a secondary location for backup and restore in the event of a failure have the longest recovery times. The second one is pilot light. So decreases your RTO to hours. So you see the previous one, you can have an, let's just go back a bit because you need to do some comparison. This one will have an RTO recovery time objective 24 hours, so that up to a day. But now when you come to pilot light, it decreases your RTO to hours, and now your RPO to minutes, but is a bit expensive, more than backup and restore. As I told you, as you move down, the cost increases. While you are trying to decrease the RTO and RPO, it comes at a cost. And that's why it depends. You should examine your deployment and also your SLA to need to see what backup what disaster recovery strategy you need to implement in regard to your business needs. Now we have warm standby. Now warm standby can be measured. RTO now has reduced. Remember, we were dealing with hours with both backup and restore and pilot. Now we have moved from hours to minutes. And also RPO from pilot light was in minutes. Now RPO is in seconds, but it's more expensive than pilot light and also even more expensive than backup and restore. The other one, the last one, which is the highest availability, so you'll have the most expensive of the 4 recovery strategies, and the RTO and RPO are close to zero, because you can't have zero but are close to zero than the rest, its counterpart. But it's the most effective strategy to reduce business impact, by the same time cost. So as you are seeing, when you move down, cost increases, your application, your deployment become more and more available, and this result to reduce business impact, but cost increases. RTO and RPO, of course, now decreases. So any question regarding, I think you're done with the second slide. What I can just add is when implementing architecture based on required RTO and RPO, you need to ensure that it's designed to fit a specific recovery timescales, particularly multi-region solutions. Questions from the audience?
Let me check in the chat room whether we have any question. So far, no question.
Okay, so we move.
Yes.
So how can you classify your RTO and RPO? So let's move now. So RTO and RPO. So we'll have your application, and your application will be running in EC2 instances, that is compute, VMs, and now database. So when defining your RTO and RPO, you need to assess, as it assesses each of your applications individually. Not all applications will require the same level of recovery response. This is very crucial because it can save you on cost. Can implement some applications are very critical, will require very like disaster recovery strategy, like multi-site active to active, but there are some applications, maybe they are legacy, they are not just that critical. You don't need to implement that because you can save you on cost. Now, the lower the number of RTO and RPO, the more complex the architecture will need to be. The more complex the architecture, the more it will cost you as a business to implement. So if specific questions business needs to answer. So when you are designing solution, you become a solution architect out there, and you have your business that is running, and they come to you in terms of disaster recovery strategies. So if a specific application was lost in a disaster, these are the questions that you need to ask before you provide a solution and choose the right disaster recovery strategy. If a specific application was lost in a disaster, what impact will it have on the business? And if lost for an extended period of time, what are the repercussions? So if the repercussions are high, you need to go for the disaster recovery strategy that offer you the lowest RPO and RTO. What if the cause of the loss from the both financial and sometimes more importantly, a reputation point of view? If financial, what are the total costs per hour of impact? So some organization, especially in the fintech sector, an outage of 1 hour can cost the company millions. So it will not be advisable to try saving costs in terms of disaster recovery strategy and losing millions in the end. And maybe you could just pay maybe 1 million extra instead of losing the million. And also your company reputation will not be at stake. Is there an associated service level agreement between specific application and your customer that use the application or service that you need to maintain? So you see, when you go even to this serious company, even like AWS, when you go, they normally have this SLM. They can tell you maybe AWS S3 has 11 nines of availability or durability or something. So if this is not maintained, you can be able to sue them for it, and then they can be able to pay you. Even your internet service provider, if he tells you like he has a backup and he has a downtime maybe of like 99% and it does not meet, you can be able to write to him or to them and be able to require compensation, because if they interrupt your business, and this is because in the context of ISP for business packages, not for home. I don't think if for home they have this SLM, and that's why for business normally have dedicated and is more expensive as they try to meet this SLM. Also on the top right, does the application act a dependency on other service or application in your business? If so, what are the implications for those should the application fail? From the governance perspective, is the application bound by any external regulatory requirements that may affect how quickly and the application needs to be backup and running? So RTO, you can choose, can be in seconds, that is multi-site active, can be in minutes up to days. Days can be backup and restore. So additional thought for identify RPO recovery point objective. Can your data be easily recreated? If so, could this be quicker than restoring it? So now it depends. If recreation is a possibility and can serve less outage than restoring it, so you can maybe think about implementing a less strict or less costly and disaster recovery strategy, which is less expensive. How often does the data change? Every second, every minute, every hour, day or week or month. This helps you to determine your backup restore. Remember, the highest RTO and RPO could give you up to backup and restore a day. So if your data changes daily, there is no need for you to go and implement an RPO, RTO that's cater for recovery in terms of seconds or minutes, because you'll be paying a lot of money, but you're not making use of such deployment. So we have the AWS Resilient Hub. This is a service. So act as a central location to help you manage, define, and validate how resilient your application are across your AWS infrastructure. So apart from doing this thing manually, AWS offer you a service that you can make use of. So there's no simple metric to determine your RPO and RTO for your resources. And remember, this differ from business to business, because different businesses have different SLA, have different use cases, have different type of customers. And depending on your internal business requirements, so it's another factor, RTO and RPO must be evaluated for an effective disaster recovery strategy. And I think we are done with the next section. So I think you now need to go to individual disaster recovery strategy. And we'll start with the first one that is called backup and restore. Remember, this has the highest RPO and RTO, but has the lowest cost. So in the exam, if you are given that your total application can withstand business impact is very minimal, but they need to maximize on costs, to minimize on cost, sorry, not maximize on cost. Can be go-to disaster recovery strategy for you. So backup and restore provide the longest RTO and RPO, best used for services that offer low-risk business impact, and RTO is measured in 24 hours or less, with RPO measured in hours. So it's good to note the difference between these strategies. So point-in-time recovery option will include that for databases, for example, for RDS, you can make use of RDS snapshot, you can make use of Aurora DB snapshot, you can make use of Dynamo backup, you can make use of Redshift snapshot, you can make use of Document DB snapshot, you can make use of Amazon Neptune snapshot. So this is just with snapshots. And for storage also, for EBS volume, Elastic Block Store, you can make also use of EBS snapshot, and you can make use of Amazon Elastic File Service when used with AWS backup. So EFS, but you need to configure it to use AWS backup. So let's move to now AWS backup. You can see it is used mostly with this type of disaster recovery strategy. So what is AWS backup? It is used to manage and implement backups across supported services. So there's some supported services that can make use of AWS backup. And with integration, so it acts as a central backup hub. So it's like backup as a service, support multiple regions, centralized management, and then view status of completed backups and restore. So when backup are taken, you can be able to visualize and see which backup have been taken and then the timestamps. And then in addition, can be able to assist you with specific compliance control. Having a managed service to monitor, control your backup allows for all logins to be consolidated in a single place. Addition also using the status of completed backups, any restore required. The service itself uses backup features from existing services. What are these supported services for AWS backup? Supported services can include Amazon EC2 instances. For databases, can include RDS database, Aurora database, Amazon DynamoDB. And for storage, can use EFS file system, also Amazon Storage Gateway Volumes. This is in terms of hybrid storage solutions, and also Amazon FSx. So we'll have a backup, then they take in terms of ABS snapshots, and then ABS snapshot can be used now to restore point in time recovery in terms of disaster. So backup policies can cover backup schedule, then backup window, lifecycle rules. You want to transit your snapshot maybe, and then a backup vault, and then regional copies, and then you can be able to tag your backups for easy identification. Now, remember, backup also support cross-region backup. When you have your deployment here, you have a region. What's that annotation? Okay, so So you have region A. I was trying to load the annotation tool. Then now we have region B in this other side. So you have deployed your application and availability zone. So you can have now your EC2 instance here. You can have your RDS instance. And then EC2 instance is making use of an EBS volume as a storage option. So EBS can be able to take a snapshot, can be able to take an EBS snapshot, as you see here. And then this snapshot can be used to be stored in Amazon S3. I remember S3 is a regional service, so it's good to store. Also, EFS file system can also be able to be copied here and then be transferred to AWS backup. For the database instance, you can take DB snapshot, and this snapshot can be also stored in Amazon S3 as a storage option. Apart from the DB snapshot, you can also be able to store transactional logs still in the same Amazon Simple Storage Service S3. So on this other side, you have now your region B. You can have now your storage solution, still Amazon Simple Storage Service, so that like this EBS snapshot that was stored in S3 can now be able to come and be copied in another region. And you have now the backup, AWS backup that is integration with the S3 service. And also we have now the bucket that stores the DB instance and can be able to restore, connect. Now you can see maybe it's grayed out because everything now works fine, but when something happens, can be able to initiate a restore in an availability zone in another region. So this you see is grayed out, but you can see it's like an EC2 instance, and then able to restore, connect to an EBS, EC2 instance or DB, that your deployment can be now back up and running. So this will be your source, and now you have your DR in another region, disaster recovery. Remember, you implement highly available solution with multi-AZ, but you can prevent now more highly available solution in multi-region, but normally it's used for disaster recovery, not high availability, but still can provide in some aspect highly available for your architecture. So connect and restore, have a EBS snapshot. So if anything happens, you can see here that is we have canceled out now. We have an issue, maybe an outage in this availability zone. Now it will come to play the snapshot that you have been taking. So snapshot taken EBS snapshot to Amazon simple storage. Now to restore is initiated. And now we make use of the MI that was taken in form of EBS snapshot. Also the RDS. But RDS you see in a single region can make just use of multi-AZ deployment. You can have a standby and then active. So all this now able to come and query the snapshot. You can see this here diagram that is stored here. Now the RDS is copy snapshot, and then go and being restored also in an RDS in a availability zone. Let's say call it AZ2. This is AZ1. So this is if it happens and you're making use of backup and restore in a single availability, in a single region using multi-AZ deployment. Single region, R for region. But what about if now you need to make use of multi-disaster recovery using now a region, a different region rather than availability zone in the same region? So the same can be happening. You can use data lifecycle management policy to be copying your snapshot to another region here. So instead of being copied in a storage solution in the same region, in a different, so we are now copying it using that lifecycle management rules and policy to copy it in a S3 store in a different region. So we have the source and you have the DR, disaster recovery. So RDS instance is running in region, let's say A, and you have now region B in this other side. So what will happen? Also can be able to migrate and copy the DB snapshot now to this Amazon S3 bucket that is stored in a different region. And if maybe now there is a failure here, now you can make use of restore feature because it's backup and restore. You backup and then in terms of snapshot, and then you can be able to restore. So MI can be able to check this is an EFS. And it's being restored to now an Amazon RDS and also the EC2 instance. Remember, it's a two-tier application. So you need to restore both the web-facing, internet-facing, using the AMI, and then you can also restore your database that is internal-facing using RDS DB snapshot. So I think for now, I'm done with the first one, which is backup and restore. You can see how it's being done. And the reason why it has the longest RPO and RTO. Any question? Or questions or clarification or addition?
I think so far good. Let me check in the chat if I have questions. None from my end so far. And
Okay.
look in the chat. No questions in the chat, unless otherwise nothing. I think we can progress.
Okay.
So
So
I don't know whether the team wants a few minutes break or we can carry on. Otherwise, the guys can let me know. Hilda, Harriet, Olu, Nema, do we take a short break? Felix.
Hi, Isaac. I joined the late though, but if they have not taken a break, maybe they will take now.
Pardon? Major new end, do we carry on or we take a like a 5 minutes break?
okay, we can take a break. You say 5 minutes or 10?
I think we can do 5. I don't know what the team wants. If guys can maybe post in the chat how many minutes you can do. But I think 10. Okay, we can do 10. Then we'll resume at 11:15.
Okay, then let's take a break and then.
All right, okay.
Okay, Isaac, are we back?
Yes, Major, we can, I think big number of guys are back. We can start. Major? Hello, Major?
Yeah, I can hear you.
Yes, you can resume.
Okay, thank you.
All right.
I think you are on the pilot.
So I didn't hear that.
I'm saying you are on the second disaster recovery strategy where there is pilot light, right?
No, the slide now, it's still the slide that I'm seeing on my end is that architecture of cross-region backup. That's what is displaying right now.
Yeah, I think pilot.
So right now it's recovery strategy, pilot light, yeah.
So what we see from the previous one, pilot light. Yeah, pilot light. No, this is the second disaster recovery strategy, and it's a bit expensive than the backup and restore, but at the same time, it has less RTO and RPO, so which means less business interruptions. Let me go to the slide now. So more complex than backup and restore strategy, comes with the introduction of data replication between regions, so it makes use of region, and then additional core infrastructure in place in the R region, in the disaster recovery region. So we'll have the source and then disaster recovery region. Some of the benefits that I can include with this disaster recovery strategy would include things like disaster recovery region in a more developed state at point of failure, and also ability to scale faster in a DR region, achieves a lower RPO due to replication and point-in-time recovery. So what are some of the questions that you can ask yourself to make use of this strategy? So continuous replication service features. Amazon has 3 cross-region replication, which will be automatically replicated objects from your source region to your DR region. For DB, Amazon RDS cross-region replicas allows you, your source RDS DB, to have a replica of the DB in a separate region created from a snapshot. What about NoSQL database like Dynamo, Aurora Global? Okay, sorry, this is Aurora. Okay, the below one is Amazon Aurora Global Database. So this provides low latency reads which can span more than one region, enables you to recover from a regional outage. For NoSQL, Dynamo Global Tables can make use of, can follow under this disaster recovery strategy where you can be used to provide a multi-regional deployment of your Dynamo DB tables without having to manage replicas. Because remember, Dynamo is a fully managed service. So this replica, these settings will be, as long as you enable it, everything will be automated. Amazon DynamoDB global clusters consist of a single primary region data store which replicates up to 5 secondary clusters in a different regions. Amazon Data Store for Amazon Elastic Cache for Redis, which can also provide the ability to work with cross-region replica cluster for low latency reads. So move to the next slide. So point of consideration, what you need to consider. So despite the application, you need additional resources to return to an operational state. You must also design your solution for a multi-region deployment. Use also AWS CloudFormation to help you manage repeatable regional deployments. So you can have an infrastructure as a code CloudFormation to automate this region failover. So let's look at an example of a 3-tier application that can make use of this disaster recovery strategy. So we have a 3-tier, have the front facing, the application, which is the middle tier, and also we have at the back end, the Amazon Aurora database. So in the first region, we'll have the active, and then in the second region, we'll have like inactive. So the deployment in the region, in the source region, is in a multi-AZ, and then traffic is being balanced using an elastic load balancer. So we'll have front-end server running in 2 availability zones, maybe let's say availability zone A and B, and then traffic is being balanced by elastic load balancer, let's say application load balancer, and they are being tied in an auto-scaling group so that if something happens, can be able to launch other instances from an MI launch template and be able up and running. That's the desired number of instances are running at any given time. And also at the back end, we also now have auto-scaling group. So the front-end services are communicating to the back-end, to the middleware services, that is the application server. And then at the back now we have the Aurora primary. And then it has a replica, or a replica that is in a different availability zone. So data between the Aurora primary and Aurora replica is being replicated synchronously from the primary region. So DR region is always ready, but inactive. So they're not running, but in case of anything being initiated, the DR region can be able to be activated. So it's not an active, inactive, but ready to be started. Let's say something like that when a failover happens. And remember, I said that you can make use of Amazon CloudFormation infrastructure as code tool to make sure that your disaster recovery region always matches your primary region configurations. So remember, things will be changing. So at the moment you configure it, data is being copied, maybe you add more security groups. So make sure that when a failover happens, as you are migrating from the source to the disaster recovery region, the CloudFormation code will make sure that these 2 regions will have identical workloads or deployments. The next slide. Now have the primary, and then have the secondary, still the same diagram. This is just trying to explain how it happens. Data is passed from application elastic load balancer, let's say LB, to front-end server. Front-end server communicate with the middleware, that is application server, and then application server communicate with the Aurora primary database or replicas in this case. And then it is asynchronously copy from cross-region replication Aurora global database with the second region. So in the moment, what happens now? If something happened, you can see X in another region. A fail happens in the region, in the primary region. So at top here, let me start my notations. So at the top here, we have Route 53 that will able to perform checks. So Route 53 health checks constantly keep checking in the primary region if all the services are active and up and running. Then the secondary So when a fail happens in the primary region using this Route 53 health check, remember we have health check for application load balance, and also we have health check for Route 53. The DR region is activated to handle traffic, either automated or manual failover. And application servers, see this application server that is, and then this front-end server. Application servers in 1 and 2 are provisioned using pre-configured AMI. So application So the AMI that is running for these instances will have all the configuration for your instances and application that if they are being activated in the secondary region, they can be able now to return your deployment, but now in a different region. And then Aurora in the DR is promoted to primary. Remember, it's now a read replica. Okay. Let's say, okay, I think I'm confusing something here. This, I'm explaining that slide. So this is like a regional failover synchronous no happens. Okay, I think I was just right. What will happen? This primary replica will be able to promote it, read replica, sorry, will be able to promote it to now to the primary, and then the AMIs, the instance level, will be able to be promoted now, not to promoted, but will be able to be used the AMI to launch instances in the DR region, that is a secondary region. So we can see failover here happens. Active now is no longer serving traffic. What will happen? Now instances, we have now the AMI has been used to launch instances in the DR region, and then we'll have now front-end servers and also application server. Then Aurora replica needs to be promoted to now the primary read replica. And now complete failover here. Now you can see now 253 is now will stop routing traffic to the region that is experiencing an outage and now start routing traffic to the DR region. So the pilot light strategy uses data replication to minimize RPO and RTO. Infrastructure is always operational in the DR region. However, provision of application server in the other resource can delay RTO if they need to scale in the event of failure. So cross-region replication is used to reduce RPO in your strategy. Always on, consider always on infrastructure is deployed in your disaster recovery region. Application server are switched off, ready to provision in the event of a disaster. So it's not active. You deploy identical infrastructure, but now switch off the moment anything happen in the primary region, they are being initiated and being turned on because always on, but now they are not active at the moment, just waiting to be triggered in case of a failover in the primary region. So I think that's it about pilot light recovery. And we can see, just mention some of the benefits of this is that your primary DR region helps achieve low RPO. So as we move from the backup and restore up to now to pilot light, you can see now the RPO is keeping decreasing, but you see the cost associated with it now increases. Then core infrastructure like VPC, ALB, Aurora replica are always active in the DR region, enabling quick recovery. So some partial of your infrastructure will be active in the, let's go back as I'm explaining. You see here, what I'm explaining is that some partial of your infrastructure, like now for the Aurora replica, will be active in your DR region, while others like the front end and the application will be inactive, just waiting to be triggered in case of an event that is happening. Also, CloudFormation can simplify deployment to ensure consistency between regions. So some can perform some form of infrastructure as code to perform automation. The only drawback is, see, this is not active. So it's active and this is inactive. We still have some higher RPO and RTO as from the next one that will be tackling the next strategies, because this will be after the need time to be provisioned and become up and running. So, and that's why we cover the next slide about warm standby, which offer a better RTO, a shorter RTO, sorry. So recovery strategy, this is warm standby. So scale down version of your primary region in the region pilot light features, backup restore features more expensive and complex than pilot lights. So it makes use of cross-region replicate. Cross-region replication, co-infrastructure running in your DR region, but in a scale version, more expensive and complex than backup and restore. So yeah, we have, as we go down, complicated increases, cost increases, but RPO and RTO decreases. Add a scaled down version of the primary production resources in the DR. This additional resources reduces RTO, provides an advantage of having resources already running in the process of incoming requests in the event. Remember the one that we were handling, pilot light, is whereby you have a portion of your deployment running. But this one now you have all your, a copy of your resources running, but in a scaled version, which means in case of anything, can be able to just start with traffic and then scale out as traffic increases. So of course, it will require an increased cost. Now this is the architecture diagram to represent now the warm standby. You can see in the primary region, region A, let's call it region A, and then this is region B. So we have identical resources by scale version. As you can see, for region A, it's running in multi-AZ deployment. All things are running in multi-AZ, multi-AZ. So we can say like availability zone, let's say 1, and then this can be like AZ 2. But now the scale version, what do we mean? The scale version is whereby now the DR region have running also still the front-end server and the application server or a replica. But you can see there is nothing that is running in the second availability zone. But auto-scaling group has been configured at each layer, whereby if traffic starts serving in this region in case of a failover, auto-scaling group can be able to launch another front-end server in a different availability zone and application server in a different availability zone. So data is copied for the Aurora replicas asynchronously cross-region replication using Aurora global database. Writing forward to Aurora primary. So in case now a disaster happened in the region M, so what will happen now? Route 53 will start routing traffic to the DR region and then balancing traffic using elastic load balancer. And as you can see now, front end, the one server that is in the single availability zone. Remember, this architecture needs to be served using 2 instances. So what happens now? Another EC2 instance is launched for front end using auto-scaling group and able to initiate this and then launch in a different availability zone to increase availability. Now application, the same applies also to application server. Auto-scaling group is able to scale and launch another application server in a different availability zone. So this is what we call always on infrastructure, because we'll have your infrastructure running in in a region, and then you'll have a scaled down version that will be running always on, that is active. In case of anything, you don't need to start spinning up server. You just need to scale. So the keyword is just scaling out your server in the second region and not spinning out like the one that we've seen in the previous example. So a scaled down version, of course, a primary infrastructure running the DR region, including web servers, tier 1, and then application server tier 2 database using Aurora replicas. So this, as you can see, always on infrastructure, always guaranteed immediate readiness to handle incoming traffic, and then reducing RTO recovery time objective. Resources availability, unlike the pilot light that we covered previously, the infrastructure, including application server and database, is already on and up and running. So what you need just to do in case of a disaster is just scaling. The previous one was that in case of a disaster, you start using an MI to launch your instances in the secondary region. So I think we move to the next one. Disaster recovery strategy, and is the last one. It's called multi-site active. So of course, as we move down, complexity increases. So this is the most complex, but since it's offered the lowest RTO and RPO of all recovery strategies, but most expensive, most complicated. So infrastructure is deployed at full scale across multiple regions. So you don't just scale down an infrastructure in a different region, but we are deploying an identical infrastructure in another region. Of course, we expect that expense will be high, because if you have a bill of 1,000 in a single region, if you do a duplicate in another region, you'll expect a bill of 2,000. And like the WAM standby is whereby it's a scale version. So if the region A as bill was 1,000 for a scale version, you'll expect maybe $500 for the infrastructure in the second region. So there is no designated DR region, as it active, not a DR region. We are serving active traffic. Application can be accessed from any region at any time. So Route 53 can be able to balance traffic in real time to both regions. So this is the architecture diagram, active. Now we have region A and now region B. Remember, we came from whereby there is nothing running in region B up to a place now we have identical infrastructure running in two regions simultaneously. Now we have two availability zones. Front end still is a 3-tier application. So front end, then application server, and application server running in the second availability zone. And now they're making use of DynamoDB. Now DynamoDB is able to serve traffic between the two availability zones. And using DynamoDB global tables, data can be able to be replicated, automatic replication, to a secondary DynamoDB to another DynamoDB in a secondary region that is running identical infrastructure, whereby you still have the front-end application running in two availability zones. So, and then of course, you need to perform DynamoDB continuous backup in each region. So DynamoDB make it possible using multi-region replication of data, ensure that data is continuously replicated, can see automatic replication between both regions, ensure data consistency and availability. So if someone is accessing application in region A, he can be able to see the same data as someone accessing application in region B. So let's move to the next slide. So we have automatic replication. So there's nothing like failover because it's active when something is happening in the region. So if anything at all happen here, so already the active, this continues. So no need of launching new instances, no need of scaling because of a scaled down version in the second region. It's just active. So just continue serving traffic using the second region. So uptime and SLM, you see you can have percentage, you can look of EC2, RDS, availability and fault tolerance. Sorry, phone was ringing. So high availability and fault tolerance. I think this is an if section. So, but now permission testing, let's just finish with the disaster recovery strategies, whereby we are now covering the last part, which was about active. So as we have seen, this is the most robust and most complicated recovery solution. Advantage is that it offers the lowest RTO and RPO. However, complexity in terms of implementation and also costs that is involved. High cost because you have duplicate workloads happening in two regions simultaneously, and the management overhead. Just give me a minute. I answer. Someone is keeping calling here. It's distracting me.
All right, that's fine.
Okay, sorry for that. I'm back. So I would like to explain some of the benefit of active, and I say that, of course, is the most robust. Cost, of course, will be high, complicated to implement, but it's best suited for critical application where high availability and immediate recovery are essential, and cost is not a primary concern. So for organization which needs very near to zero business interruption can make use of active, multi-site active, but of course it comes at as a higher cost and also complicated in terms of implementation. So the next part that we're discussing is high availability and fault tolerant. So I think I've been talking a lot. I need to engage my audience. If I may ask the difference between high availability and fault tolerance, what's the difference between the two? Isaac, I think there is Hilda and the Herman, Olu. What's the difference between high availability and fault tolerant? Do they mean the same thing? Related?
No, I don't think they mean
Yes.
the same thing. They have different meanings. So with their availability, I think the major goal is to minimize downtime and ensure that the system is available for use for a very high percentage, let's say 99.99%. Whereas when you look at fault tolerance, the goal of fault tolerance is to ensure a continuous uninterrupted operation even in the face of even if there's a component of the system that has failed. So I think that's where the distinction is.
Yeah. So high availability is focused on maintaining operational. You are very right, Isaac. Status by minimizing downtime and failures, making use of things like availability zones, making use of regions. But on the other hand, now fault tolerance provides zero downtime, during which failures and is often more complex and costly. So it's a difference. These things about minimizing downtime for high availability, but for tolerance, it is sure that zero downtime, like near to zero downtime, and for failures, during failures, and often, okay, more complexity because like more advanced in terms of implementation. So things to do, like percentage of uptime to do with SLA, EC2 instance, RDS, and S3. So if you have your deployments running here, like diagram, you have it availability zone 1 and then availability zone 1. If something happens, if say you have implemented design for failure in one availability zone, the second availability zone should be able to serve traffic for your applications. So you can't see here, but now things like cost increase in uptime. So application can have two running like here below that we are discussing in two availability zone. Let's go to the next slide as explained. So high availability, you can make use of the first one. You are looking about making the application highly available using a single region in two different availability zones. But also you can make use of multi-region deployment. Okay, so it's back. So you make use of US East 1, US West 1, and then US East 1. And inside, so you have multi-AZ, multi-region. So same application is a two instance deployment running into availability zone using application.elastic load balancer balancing traffic between the two. Here, you have your duplicate. So this will be like the multi-site active that deployment that we discussed lastly about disaster recovery strategy. Have your application running in multi-availability zones in multi-region, identical application running in different regions. Side. Post DNS. Now we go to the next section, that is using AWS storage gateway for on-premise backup. Still, we are on strategy about maintaining highly available architecture of the application designed for failure. So if I may ask, according to your storage now, I think we all learn storage. What are AWS storage gateway? I believe by now we would have done about storage, and AWS storage gateway is one of the solutions that was covered during those discussions. What is AWS storage gateway?
I'll give it a try.
Yeah.
I think it's essentially it's a bridge between the on-premises environment and the AWS cloud storage services like the S3, the EBS, and the maybe Glacier.
Yeah, very correct, Isaac. So AWS Storage Gateway offer you a hybrid storage solution. So you can do a combination whereby you store data both over in an on-premise data center and in the cloud. So can be provide the application highly available. You can make use of S3 like a backup in the cloud, or can be just for compliance reason, whereby you have some data that cannot leave your on-premise environment, but you still need to make use of the scalable storage solution that is offered by cloud. As you can see here, now you have like your corporate data center, and then you can use network attached storage, NAS, and the DAS. Using storage gateway can enable you to make use of cloud scalable storage solution like S3, which is virtually unlimited. I don't know, remember where someone said that his bucket was full for using Amazon S3. So that is virtually unlimited. So what is being done is a software appliance that can be integrated on-premise on AWS, and the appliance can be downloaded as a virtual machine and installed on VMware on Microsoft hardware. So there are three flavors that you can make use of the storage solution. One of them is the file gateway. Another one, you can make use of volume. Gateway, and you also can make use of tape. Gateway. Normally called VTL, Virtual Tape Library. So let's move on to the next slide. Yeah, so appliance can be downloaded as a virtual machine. Two different configurations can be available. So you can make use of file gateway as we discussed. So in the file gateway, store file object in S3 as file share. So remember EFS, like similar option now in terms of how data is being stored. It can be mounted using, okay, and also in the volume, let's just discuss further how it's being configured. And in the volume gateway has two configurations. You can have stored volume gateway and you can have cached volume gateway. On the tape library, this is more of like a cloud-based tape backup solution replacing the physical tapes and virtuals one. So let's start with the first one, which is the file gateway. So allow you to store securely your files as objects within S3. Ability to mount or map S3 bucket as if it was a share held locally. So we have application, have file gateway, and then of course, data transfer happens in a secure HTTP. So HTTPS, and then you have now server-side encryption. Make sure data now is encrypted in the cloud. So file gateway can enable you to access your data that is like S3 bucket is like mounted in your on-premise infrastructure. So corporate data center. So your entire local data can remain on premise, ensure low latency data access. So we'll have corporate data center application. You can use CASI, and then you can use NAS, DAS, and then synchronously, that is asynchronously being copied to S3 bucket. And some of just to note about, let me go back a bit. On this file gateway, enable to store files and objects within S3, ability to mount map drive S3 bucket as if it was shared locally. And very important thing, just to remind you, I think you did this. Some of the protocol that are being used for this is NFS version 3 or NFS version 4. Apart from this, was a very important addition to know. So you can use NFS version 3 or NFS version 4. Now let's move to the second flavor of storage gateway, which is the volume gateway. So for volume gateway, used to back up your local storage volumes to S3, the entire local data can remain on premise, ensuring no latency. So for this is what we call stored volume. So the first one from the flavor, we can use stored volume. So the stored volume gateway can come as stored and then can be as cache. Just a quick reminder of how you can now note the difference in terms, maybe you're confused. The names and the types of stored volume gateways is based on if data is stored in your data center. So for stored volume, it means that all your data is stored in data center and asynchronous copied to AWS cloud just for backup. While cache, which means now your data is not stored in data center, is stored in S3, and only a subset of your data, frequently accessed data, is being stored in your data center. That's why you see cache. So is it cached in your data center or is it stored? So if it's stored fully and just a backup is being sent, we call it stored volume. If it's being cached and the primary database, the primary data storage solution will be S3, and just a subset of your data is being cached for low latency for the frequent access data. So make use of SCSI, NAS, DAS. So another thing that you can ensure, let's go to the next slide, about these stored volumes, setting up the type. Volumes can be between 1 GB and 16 terabytes. Each storage volume can hold up to 32 volumes. So maximum storage is 512. A minute. When you take 32 times 16, you get 512. Yeah, I was right. I was trying to do something. So remember, volume can have a maximum size of 16, and each storage gateway can hold up to 32 volume. So if you take the 32 volumes and then you multiply by the maximum amount of maximum size that a volume can have, that is 16, should now be able to give you the maximum storage you can have per storage volume, which is, sure. So it will be 32 times 16, and then it gives you 512. This is the maximum. That's how we get the maximum. We take this, the maximum volume can be, and then how many volumes you can have. So 32 times 16, you get 512. A storage buffer using on-premise storage is used as a staging point for data. Data is uploaded across SSL channel and stored in an encrypted form. Snapshot can be taken of volumes at any point and stored as EBS snapshot on S3. So stored volume gateways. So remember, you have stored and cached. So for stored volume gateways, no access to on-premise application or storage tiers. So you'll have your application server, corporate data center, and then now you have the S3. So EBS snapshots are taken from the corporate data center and then being sent to S3 storage for backup. So for the stored volume, just using like up for backup. All the data is still residing in data center. So can use the stored MI volumes and EBS snapshot can be used as a disaster recovery. In case anything happened, the volumes can now be copied and then launched in the data center so that business can continue being operational. The next one is the cached. So the primary data is storage provided by S3. So previously the stored one primary is data center, and then you just copy backup data to S3. So this S3 is the primary source of data. Local data is used for buffering and local cache for recently accessed data. That's why the name cached volume, because on the data center, you are just caching the frequently accessed data. So for the cache volume, each volume can be up to 32 terabytes. And the storage gateway can support up to 32 volume gateway. So for this one, now will be not that 32 times 32. I don't know if it's 900 and 1,000. Let's see. Yeah, and that's why I give total storage capacity of 1024 terabytes cached volume gateway. Snapshot of the volume stored on S3 as EBS snapshot. So still snapshot can be saved in S3 as EBS snapshot. So we move to the next type of storage gateway, which is the virtual tape library, which we normally call it VTL. So it allows you to back up data to S3 from your on-premise data center, leveraging Amazon Glacier for data archiving. So virtual tape library is a cloud-based tape backup solution replacing physical components with virtual ones while utilizing existing tape backup application infrastructure. So for those people who still have legacy storage solution, virtual tapes can make use of VTL for their hybrid storage solution with AWS. So what are the components of VTL? So VTL components will include storage gateway. This is configured as a tape gateway acting as a VTL with capacity of up to 1,500 virtual tapes. And then you have now the actual virtual tapes, which are equivalent to physical tape cartridges capacity of 100 gigabit to 2.5 terabyte. Data stored on VTL are backed by Amazon S3 and visible on the virtual tape library. VTL virtual equivalent to tape library containing virtual tapes. Tape drives, each VTL comes with 10 tape drives presenting as SCSI devices to your backup applications. Media changer, these are virtual device representing a SCSI device to back up your application that manages tapes between your tape drive and VTL. So your tape drive, this is on premise, and then VTL, that is that on the AWS cloud side of things. Archiving, equivalent to an offsite storage facility, giving you the ability to archive tapes from your VTL to Amazon Glaciers. So yeah, for data archiving can be used. So it includes storage gateway, virtual tapes up to 2.5 terabytes, and then the VTL, tape drives, media changers, and also now there, you can also do archiving. So gateway, virtual tape library, your application and backup software can mount tape drives using the media changer as SCSI device. You can create virtual tapes and when you need them to back up your data, which remember are stored in Amazon S3. For all these storage gateway solution, they're making use of S3 storage as their primary data, as the data source in AWS side of things. Support third-party applications, so you can say documentation, user guide, and then archiving moves from the Amazon S3 to Amazon Glacier. So I think I'm done with the storage gateway. Unless there is a question. In summary, we can say that file gateway can be used for storing files as object in S3 with NFS access or NFS protocol version 3 and 4. Volume gateways offer, you can either use stored. Stored is whereby all your data is stored in your on-premise and you are using just S3 as backuping your data. You can use cached. Now we are using S3 as the primary data source and we just cached your frequently accessed data in your on-premise. And then you have the tape gateway, which are cloud-based tape solution and virtual tapes stored in S3 for archiving in Glacier. So any question up to that point before we move to RDS multi-AZ deployment? Remember, we're talking about high availability today. Any question, any clarification?
No question. Let's move on.
Okay, so what is RDS multi-AZ? I think this is about database. Someone else can speak. Isaac, you've been very active. I know you have your colleagues here. What is RDS multi-AZ? So I can remind ourselves when we go to see the implementation phase of it. I think we're meeting Harriet, but Hilda, Gerard, what is RDS multi-AZ?
Okay, so RDS multi-AZ is whereby you have a primary database in one availability zone and you have a secondary databases in the other availability zones that are present, and there is replication to the other two databases. So in case the primary database is not available, then the secondary database will become the primary database, and thus you can be able to read and write, and a new database will be created in another availability zone that will act as the secondary database, which data will be replicated to the secondary database.
Okay, that is well said, Gerard. Yeah, multi-AZ is whereby you have a database running in multiple availability zones. So it happens, as Gerard explained it, you have your one act as primary and the other one is secondary. So in case of any failure in one availability zone, the secondary will be promoted to primary, and then RDS will start now to launch another database in a new availability zone, and now will be serving as secondary, so that in case of something happens now to the primary, which is promoted to secondary, to the secondary which is promoted to primary, the secondary also can be now promoted again to the primary. So we'll make sure that your database is running in multiple availability zones at any given point in time. So it is a feature that is used to help with resilience and business continuity. Multi-AZ configure a secondary RDS instance, that is the replica, within a different availability zone in the same region as the primary instance. So we can have the one, you can call it master or primary. So you can see is in AZ1. And you can have a standby replica. So in AZ2. So you see this is region, maybe let's say US. East 1, and then you have 2 regions. So the database will have master and secondary. The only purpose for multi-AZ is to provide a failover option to a primary for a primary RDS instance. So something can happen. It doesn't have to be the availability zone being out. Something can happen also in your instance that is running your DB. So if such happens, you can be able to now fail over to the secondary, and now this is promoted to primary or master. And then maybe if you have now another availability zone, so you may try to launch, RDS is somehow a managed service. So it does not disclose how it happens. So will it try to launch another one here, or will try to launch another one in a different availability zone? So that's, I think, AWS node implementation. But for you, just need to know that at any given point, when this is promoted to master, and then here now we'll come and have now secondary. So secondary, in case outage, in case of this has an outage, so this one will also promoted to master, and then maybe now the process go on, making sure that multiple copies of DBs are being run in a region. So the replication of data happens synchronously, so like real time, and yes, uses a failover mechanism on Oracle, MySQL, MariaDB, and Postgres instances. So these just are database engines. The RDS failover process happens automatically and is managed. As I say, it's managed service. So you don't need to worry if something happens, how would the failover happen? Because AWS has taken care of the implementation side of things. So RDS update the DNS record to point to the secondary instance within 60 to 120 seconds. So you can see in at most 2 minutes, the instance, the DNS record will be updated, and now you are the secondary now will be able now to become the primary to serve traffic. So the failover process will happen in the following scenario on the primary instance. 1, if patching maintenance is happening to the primary instance, also host failure. So the instance that is running your RDS has a failure, availability zone failure. So if there is an outage in the whole availability zone that's running your DB instance, of course, you'll be able to serve. And also instance rebooted with failover. So if it's rebooted, the failover error, DB instance class is modified. So if it's modified, we need time, and that time can be more than, we see how we have top 2 minutes. So if you modify and take 2 minutes, you expect now to experience outage of like 10, even up to an hour, so you get database to be up. So if your database makes use of multi-AZ, you'll be able to update the DNS to point to the secondary as a primary, as the DB now, the modifications is underway. And when the modifications completes, now can be able now to serve now this as a secondary when it comes back up, and this will be serving now as the primary. So very important to know some of the instances. You can be able to ask patching maintenance, host failure, availability zone failure, instance rebooted, and also the B instance class modified. So how can you be made aware of when this event occurs? So the RDS failover triggers an event which is recorded as RDS event #0025 when the failover process is complete. So using an event notification, so RDS will send an event notification to you. For maybe more use of how this happens, as I said, it's a managed service, but you can see the workflow of how it will happen if for failover to happen for your primary to become, for your server to become the master. SQL Server in multi-AZ also is achieved through the use of SQL Server mirroring. Multi-AZ is available in SQL Server 208, 2012, 2014, 16, 17, and both the standard, on both the standard and enterprise edition. So from 208 upwards up to 2017, SQL mirroring also provision a secondary RDS instance in a separate AZ than that of the primary RDS instance to help with resilience and fault tolerance. Both primary and secondary instance in SQL Server mirroring uses the same endpoint. So that's why you see when doing a failover, the endpoint, the DNS will need to be changed to point to the new master or the new primary that has been promoted from the secondary. You need to ensure that you have the environment configured correctly. What is this? At DB subnets group must be configured with a minimum of 2. So when you go to deploy a database, if you have done a lab, or maybe you have done some challenge, a DB subnet group must configure to run subnet group 2 or 3. So minimum of 2, because remember the master and the primary cannot be running in the same availability zone. So that's why one of the requirements. You need to also specify availability zone for standby mirror instance will reside. So you have some flexibility, some control to decide where will the primary and the secondary be running. To check which AZ standby instance is, you can use AWS ls command, and then the command is describe DB instances. Aurora. So Amazon Aurora DB. I remember you have now from RDS multi-AZ, which is a managed, but Aurora now is different because Aurora is a fully managed. Remember, previously we learned some of the requirements you need to do, security groups, defining where you need to reside, but Aurora is now a fully managed SQL database. Previous DB, when it comes to resilience across more than a single AZ. So Aurora DB cluster are fault tolerant by default. Remember, for RDS, you have the option to choose if to run into multi-AZ or a single AZ. But Aurora is like a serverless, fully managed service. You can maybe be able to choose, you can run Aurora in your single database. So it must run in more than one availability zone. And all this is taken by AWS since it's a serverless database offering. Aurora DB cluster are for tolerance by default. It's achieved within the cluster by replicating the data across different instances in different AZs. Aurora can automatically provision and launch new primary instance in the event of failure, which can take up to 10 minutes. Multi-AZ on Aurora cluster allow RDS provision replica within different AZ automatically. So you see primary instance here, and data copies, and then you have data copies in 3. These are 3 availabilities on 1, 2, and 3. So if something happened that is just affecting the host instance, can be able to, that data copies now can be able to be promoted. If it's affecting the whole region, what will happen? Now we need to go and update the whole, upgrade the data copies in in a different availability zone to become the master. So Amazon Aurora is different to the previous DB engines when it comes to resilience across more than a single AV. So Aurora, you have the primary and then data copies, and then you have Aurora replicas running in a different AZ, Aurora replica in a different AZ. So data copies, and then make sure that replicas are running in 2 different availability zones from the primary instance. Should a failover occurs, the replica instance is promoted to the new primary instance without having to wait the 10 minutes. This creates highly available and resilient database solution, and it is possible to create up to 15 replicas if required, each with different priority. So we have been talking about replicas. What are replicas? Let's take a look. let's take a look at them. So read replicas are not used for resilience or a secondary instance in the event of a failover. Read replicas are used to serve as read-only access to your database data via a separate instance. So if your database has a lot of read traffic, there's no need to provision a duplicate database with read and write. You can just provision a read replica, and the read replica can be able to be serving read traffic. So you can direct all read traffic to the read replicas. So a snapshot is taken for a database, and once a snapshot is completed, a read replica instance is created. The read replica maintains a secure asynchronous. Remember, for the other database where multi-AZ is was synchronously. So this is not close to real-time as multi-AZ deployment. The read replica maintains a secure asynchronous link between itself and the primary database. At this point, read-only traffic can be directed to the read replica. Read replicas are only available for MySQL, MariaDB, and PostgreSQL DB engines. So we have the primary DB instance in AZ1, secondary DB instance in AZ2, and now we have your read replica. And also it's good to know that they are also supported in Oracle and Microsoft SQL Server database engine. So it is possible to deploy more than one read replica for the primary DB. As you can see in the diagram here, you have the primary, secondary, and in AZ4, you can have replicas in different availability zones. And this is a region A, and this is region B. So we have read replica and read replica here, one here and then one the other end. Adding more replicas allow you to scale your read performance in a wide. So a question mostly is asked a solution architect exam. I have an application, someone has set up environment, and the application is experiencing a lot of read traffic. What can you do to maintain, to cater for this excess traffic while maintaining the cost low? So you see, for read replica is not like active, you can make use of read replicas. That's mostly, and it's a very common question, testing you on how you can employ how good are you in providing solution for AWS, when to use which service. Adding more replicas allow you to scale your read performance. So read performance is the issue is experiencing a lot of read traffic, make use of read replicas to a wide range of applications. You are eligible to deploy read replicas in different regions. So it's not only supported in multi-AZ in a single region, can be able to use in different regions. It's also possible to promote an existing read replica to replace the primary DB in the event of an incident. So in the event of a failure, read replica can be promoted to become the primary. During the maintenance of the primary instance, read traffic can be served via your read replicas. So what about read replicas on different engines? So as I said, it's supported in Postgres, MySQL Server, and MariaDB. Read replicas also only supported where the source DB is running MySQL 5.6 or later. So this is one of the requirements. Any DB engine serving MySQL 5.5 and below cannot be able to qualify for read replicas. The retention value of the automatic backups of the primary DB needs to be set value of 1 or more. And then replication is also possible when using InnoDB storage engine, which is transactional. It is also possible to have nested read replicas chains. A read replica replicates from your source DB and then can act as a source DB for another read replica. this chain can only be a maximum of 4. So what does it mean? Here you have your primary, and here you have now read replica 1, read replica 2, read replica 3. So can be chain a maximum of 4. So this can be served as primary for this DB. And this also can be served as primary for this DB. But you see the levels from the primary. This will be 1, 2, 3, 4. That's why you see this chain can be only a maximum of 4 layers deep. Whereby now this act as a source. So copied here, and then this now copied to this one, and then also this data copied to the next read replica. Use the same principle must also apply to the source read replicas. You can have maximum up to 5 read replicas per each source DB. It's also possible to have nested read replicas. A read replica replicates from your source DB and then act as a source DB for another. So nesting, what you have now. This, let's say 5 read replica, and then this one now serve as a source to the read replica in the previous level, and then also this serve as a source to the read replica in the next level. This chain can only be have as maximum of 4. So 1, 2, 3, 4. Same principle must also apply to the source, and it must have maximum of 5 read replicas per each source DB. So I think up to 5 read replicas. So see master. So this is the like source, also the primary. So can have 5. So you can see a 1, 2, 3, 4, 5. And the levels can be up to 4. So you can see this one source and they're serving for this. This is second, this is third, and this is 4. So that is what is meaning in this. A maximum of 5 read replicas per each source. So this one can have 1 up to 5. And now the levels source read replicas this second, and then this read can have as a source this below read. This is a third, and then this read can serve as a source to the 4th read replica in the levels. It's also possible to have nested replicas. If an outage occurs within your primary instance, RDS automatically redirects the read replica source to the secondary DB. Amazon CloudWatch can monitor the synchronization between the source DB and the read replica through a metric known as replica lag. So good to know about replica lag. What about read replica in MariaDB? In MariaDB database engine, you can still have the backup retention period greater than 0. And you can only have 5 read replicas per source DB. 5 read replica per source DB. The same read replicas nesting rules apply, and you also have the same monitoring metrics for CloudWatch. You can be running any version of MariaDB for read replicas. So remember, MariaDB is one of the database engine that is supported for read replicas. Other one is PostgreSQL, other is MySQL Server, I'm not wrong. The automatic backup for Postgres engine now, the automatic database engine, that is, the automatic backup retention value needs to be greater than 0, and the limitation of, so see, this still have a limitation of 5 replicas per source DB, and you can now have up to 15 replicas from 1 DB instance within the same region when using MySQL. So if you use just MySQL native, not no flavor like Postgres, custom database engine, you can have up to 15. But for Postgres, you can have still 5 per source. So the automatic backup 5, and then when they're using Postgres, you can need to run version. So remember, MySQL was version 5.6. So Despite PostgreSQL being also an SQL database, uses different versioning because it's a customer. It's not this using the native MySQL database engine. So this you need to have running or later. So from 9.35 to any version above it, that's what supported replicas. The native PostgreSQL streaming replication is used to handle replication and creation of the read replicas. The connection also between the master and the read replica instance replicated asynchronously between the two instances. So multi-AZ deployment synchronize data asynchronously, while read replicas for all database engine data is being copied asynchronously. So it's good to note the difference. So a role is used to manage replication when using Postgres, and Postgres allow you to create multi-AZ read replicas instances and does not allow nested read replicas. So remember the other such database engine allowed nesting up to 4 levels, but this does not allow nesting, but it's allow read replicas 5 per source, but no nesting for PostgreSQL. I think I'm done with the multi-AZ deployment. Now maybe we move to, and that multi-AZ was about relation databases. Now we're moving to AWS DynamoDB, highly available option. This is a NoSQL database. Any questions? Hello?
No questions.
So we move?
Yeah, we move.
Okay. So as we move, DynamoDB, highly available option. I think just a reminder, we know that DynamoDB is a fully managed, highly available NoSQL database offerings in AWS. So NoSQL schemaless managed service built and provided by AWS, designed intentionally to automatically partition data and incoming traffic across multiple partitions. Also, partitions are stored on numerous backend services distributed across 3 availability zones within a single region. So being a fully managed service, provide high availability by default. So they say design internally, automatically partition data and incoming traffic across multiple partitions. So what are the partitions when you talk about DynamoDB? A partition which can be referred to as a dedicated area of storage attached to a data table and is automatically replicated synchronously across 3AZ within a particular region. So we see for multi-AZ deployment, when you need to deploy copies, we use synchronous replication. But for read replicas, we use asynchronous data replication. And good to know that this partition, of course, they are being done automatically. The amount and required availability can be increased using and configuring additional option as we'll cover next. The slides. Let's go to the next slide. So DynamoDB partition, as I said, just a reminder, this partition, what we talk about, these are just dedicated area of storage. As the way you can partition your hard disk, you see, hard disk, you can have your machine that's having a 500 gigs of storage, maybe HDD or SSD. But remember, operating systems allow you to partition that hard disk. So you have 500 gig, but you can be able to partition maybe 100 and see dedicated that for operating system and application system software to be stored there. And then you can partition maybe 200. You say now this is for storage for personal use, and then another 200 maybe for partitioning for storing VMs. So the same thing can happen here. Dedicated area of storage attached to the table. Remember, DynamoDB makes use of tables. and is automatically replicated synchronously across 3 availability zones. So you see availability zone 1, availability zone 2, automatically, remember, and then availability zone 3. So if you have in a single region, the next region, if you use global tables, so you can have the same thing, 1, 2, and also 3. And Dynamo is the one that manages things automatically, the replication. So you don't need to configure anything. So what are the advantages of having to partition and replicate data in 3 availability zones? This can provide you with things like protection against single node failure. So if anything happens in this zone, you can see you have also zone 2 and 3 serving a traffic. If also something happened in this, you still have another zone, zone 3, that is able to serve the traffic. And it's good to know that this replication happens in sub-second intervals. Let's go. Remember I said this thing is automated. So DynamoDB take care of performing both the partition management and replication. So replication and also the management of replication, DynamoDB takes care of it. Remember, full managed service. The synchronous AZ replication provide protection against any single node outage. So if node out is node in AZ1 is out, this can still be able to have traffic, or a full availability zone outage. So you see this is region A, region B. So if it's the whole region that is affected by the outage, what will happen? Now the region B now will be able to serve traffic. The synchronous replication takes place with low latency that interconnects between each availability zone within the region. Hence, of course, we are expecting high speed of sub-second replication. So dialing up and down for provision throughput. So can I able to set a configuration throughput database is possible to ensure that DynamoDB database can meet the needs of your application as it grows. So you can do a provision input throughput whereby you define in advance the throughput that you need for these DynamoDB partitions. So the throughput can be in form of read and write capacity. So I think RCU and there's write capacity unit, WCU, if I remember my database, write capacity unit, and also RCU, whereby you can provision also read capacity unit. So these are for writes, write capacity unit, and these are now for reads. So you can provision read capacity unit. The reason why AWS has subdivide this, because remember this, when you provision this, they incur costs. So maybe your use case can be your application is just read intensive. Why need to come and provision write units while you just need read? So you can just come and provision higher read capacity unit. What about if your application is just write intensive? You can just come provision write capacity unit, WCU. So let's move to the next slide. So dialing up and down provision throughput database is possible to ensure your database can meet the needs of your application as it grows. Yes, I think you talk about that. So we have something in DynamoDB that we call global tables. So what are global tables? This provides a secondary layer of availability in a form of cross-region replication. I think if you go back a bit, this. Yeah. Let me clear this slide. So global table is whereby this DynamoDB partition can have in regions using global replication. So you have region A. Remember the partition happens in 3 availability zones by default. So 1, 2, 3. But now you can do replication from this region to the second region. And that's why we call now the global tables. And this is offered by default by DynamoDB. Like you don't need to configure, you can just enable it. You don't need to go and do it manually. So Dynamo provide a secondary layer of availability in a form of cross-region replication, global tables, and global tables gives you the capability of replicating a single table across one or many alternate regions. So global tables elevate the availability of your data and enables application to take advantage of data locality. Remember, for data disaster recovery strategy, we talk about active. And you see when you go to active, the database change from RDS now to DynamoDB, because DynamoDB can be easier to implement, making use of this feature of global tables. As remember, as I said, the multi-site active has the highest, has the lowest RPO and TO, but in terms of implementation can include a lot of complexity and a lot of cost. So to use my service that offer these features automatically out of the box can be good. You just need to activate them because they cannot be activated by default. They incur cost and maybe you don't need for the global tables. So elevate the availability of your data. So you see using regions and enables application to take advantage of data locality. Users can be served data directly from the closest geographical locations, located table replicas. Okay. Okay. So, yeah, I was talking about global tables elevate the availability of your data and enables applications to take advantage of data locality. Users can be served directly from the closest geographical locations located in the table replica. So we have region, so here like in South America, regions here in the US, so global tables to see in one or more regions can be able to make use of global table. So if you have your application in US East 1, and now you also have some customers, I think this is Middle East, if I'm not wrong, or maybe let's say Australia, I'm sure this is Australia. So if this is Australia, so using global table, replication can be happen, and your user that are located in Australia can be able to be served traffic with the global DynamoDB table located in the Australia region. Any questions?
No, no questions.
Okay, let's move, see if we can finish this today. High availability. So global implement multi-master read and write capability with eventual consistency. So both read and writes can be performed against one of the configured tables. All writes within the will then be replicated in the near sub-second to time to all other global configured tables of the same table name. Existing DynamoDB. This DynamoDB table can be converted into global tables, either using relevant configuration options exposed within AWS DynamoDB console or by using AWS CLI. So you can use console. This is the web version. And then you can use CLI command, executing this command. So command that can be run for the CLI is AWS DynamoDB update table. So that's how they can be converted into global tables. Remember I told you that tables are, Dynamo by default is a regional service, but you can be able to enable global tables to make use of multi-region deployments. So I don't think we have time for demo. Let's see if we can just get time after we finish the slide, because I was supposed to cover high availability today. So another thing that we can discuss is on-demand backup and restore. So we see backup and restore is one of the disaster recovery strategy which offer the highest RPO and RTO, but offer the lowest cost and also the simplest in terms of implementation. So just let's think about it. So on-demand backup allow you to request full backup of a table as it varies the moment of the backup request is made. And on-demand backup are manually requested and can be performed either through DynamoDB console or by use of CLI. So support both programmatic configuration or using graphical user interface of the web. On-demand backup are useful in the following. So the table corruption, rare but possible, long-term regulatory compliance and audit of data requirements, and then testing scenario. Schedule backups. So scheduling a backup involves with the ability, provides you with the ability to restore tables data back to a point in time. On-demand backups remains in the account until they're explicitly requested to be deleted. So that's one of the distinction between on-demand backups and scheduled backup by administrator. Backup typically finish within seconds, so very fast, and have zero impact on the table performance availability. So scheduled on-demand backups. So can be scheduled, always ability to restore back in times at point, and then for deletion, they'll stay there until you administrator schedule deletion. About point in time recoveries. So you can take backups at different points. Clear this annotation first. Point in time recovery, PTR. So you can have point 1, point 2. This is a time that a backup can be taken. This is extremely handy in a situation where you are modifying data and you want a safety net in place for situations where your data modification didn't result in a way you should have. So you can take your backup at different points depending on how frequent your data is changing in your DynamoDB table. So you can have like point 1, point 2 that is highlighted. PTR operate at the table level and provide you with the ability to perform point-in-time recovery for any time between the current time and the last 35 days. So point-in-time recovery can go up to 35 days back. The feature needs to be enabled as it is disabled by default. So when you provision a DynamoDB table, this feature is not enabled. The restoration will always be performed into a new table, and table restoration can be performed in the same region as the original table, or into a different region altogether. So when point-in-time recovery are taken, you configure enable it. One can be either performed in the same region or can be done in a different region. So I think there's a demo lab here, but let me just, because of time, we started late. So what are the summary regarding what we have learned? Migration. Migration, large amount of objects on-premise to AWS region. You can use AWS Data Sync. And then you need to install Data Sync agent in your on-premise and protocol that can be used for, as an on-premise, you can use NFS, SMB, S3, and API. And then, of course, your migration is secure as a form of a TLS. So in case of any compromise, no one can be able to read your data. Migration scenario, large amount of object. On this case, you can use of Snowball devices used for large volumes. And whereby Snowball can use whereby your internet is limited. So migrating data from Oracle, Microsoft Server. So you can use, this is called DMS, Database Migration Service. So for this production database on premise, you can be able to use DMS. You can be able to use DMS, Database Migration Service, So of course, an agent still will be installed in your premise. So agent, do assessment, and then now you can be able to be connected and then perform the migration to development and testing in the cloud. It's not a good practice. You cannot migrate directly to production. So what are the migration scenarios? You can migrate to your EC2 instance, ephemeral storage, EBS for persistent volume. But you see, this is grayed out because it's not highly recommended. And then you can also migrate Amazon S3 object storage. Then you can make use of Amazon Glacier for archiving, data archiving. So migration scenario, also storage, you can make use also of Amazon EFS Elastic File System, and then you can make use of Amazon FSx for Windows File Server, which is fully managed file service. Most requirements, suite most requirement where you need shared access and file. Remember, EFS is mounted. It can be mounted, and then multiple institutions or multiple service AWS service can be querying data from the mounted drive. Still on a migration scenario of storage, can use Oracle Cluster File System, OCFS, and also Red Hat Global File System, RHGFS, then database cluster. Throughput, select POPs, provision IOPS. So provision apps IO2 size, you can select size up to 16 terabyte. You can see there are 4 GB up to 16 terabyte IOPS. So if you need provision now 2500, so minimum is 100, maximum is 64,000 IOPS. Throughput not applicable, and then you choose availability zone, and then snapshot, and then multi-attach can be enabled. Need to check. I think this is for demo. So Nitro-based VPC multi-attach file system, EBS volumes, and then shared volume SSD IO1 and or IO2 EBS volume up to 64,000 IOPS. Red Hat high availability 2-node cluster, GFS file system, and also Nitro-based instance. Remember, Nitro-based instance are the one which support EBS multi-attach, if I'm not wrong. So and then you have the EBS volume. Still on the migration scenario of storage requirement database, run database or database cluster on a single EBS volume, need to support 64,000 plus IOPS input-output performance operations, be able to access that volume from one or more EC2 instance. Pattern, use Nitro-based EC2 instance here. So I said, sorry for that. Nitro-based, the one supports multi-attach. Use IO1 or IO2 SSD EBS volume. Support multi-attach for EBS volume. Remember, for EFS can be attached to any EC2 instance, but for the EBS, if you use to enable multi-attach, you need to use specific type of instance that is Nitro-based EC2 instances. And then you can be able to enable multi-attach options. High availability, some of the exam tips that can become getting your data in and out of AWS. So migrating data in and out of AWS. One, you can use direct connect. Then you can use VPN, and then you can use internet connection. Also AWS Snowmobile, and storage gateway. Which among these are the security has been put in place? Because you see, we do not recommend internet connectivity because your data is passing through the internet. Since even if you use TLS, but it's good to use either VPN where it keeps your data. Direct connect, these are private links. And also Snowball, this is offline data storage, which they have security model, also security in place. If it takes longer than a week to transport, so you need to take time that you need to first request in provision and then send it back. But with VPN, I think is one of the fastest one you can do, either site to site or client VPN. Direct connect is fast, but also take time to request the direct connect link to become and the cable being laid out, and it can take months. So when it's urgent, but it's the most secure for direct connect because it's private, dedicated link from your data center to the AWS cloud. Getting your data in and out of AWS, we are talking about that. And then if you need to shift more than 50 terabyte of data, Snowball device is usually the best option. So if the data is that huge, Snowball can be a good candidate. Recovery time objective, the speed in which you need your system to be back up and running, while that is RTO. While RPO, the point in time you need to go back into the data. So RPO in terms of data loss, RTO in terms of interruption. What amount of time can you withstand interruption for your business? 3 classes of Amazon S3. You have the standard, infrequent, and then glacial. And then I think they added single zone one, infrequent access, something. Has S3 standard has 11 nines of durability because your data is saved in 3 availability zone by default, but the cost is not as cheap as single AZ. Maintained by data being replicated across multiple availability zones within a single region. Remember, S3 is a regional service. Has 4 nines of availability and security features, including encryption, access control, data management functionality, and lifecycle policies. Very similar to standard. Now we have S3 infrequent access, but only 3 nines of availability as opposed to 4. Infrequent access is cheaper than standard, making this a very good option for backup, but your data retrieval time is higher retrieval cost. The cheapest option, the Glacier archiving, is the cheapest option of the 3 classes used for cold storage, data archiving, and uses different security mechanisms, such as vault policies, and you can use S3 lifecycle rules or SDK to move your data from one of the other classes to Amazon Glaciers. This does not offer immediate access to your data. Remember, it's for archiving, so they're just expecting you to access your data on a day-to-day basis. And the speed at which retrieval will depend on the method you choose. So you can have expedited. I think expedited, you can have your data, I think, from 1 hour, 5 minutes to hour, and then you can have standard, then you can have bulk. And for the retrieval, there's a fee for retrieving data from Amazon Glacier. Cross-region replication used to help the disaster recovery by reducing latency of data retrieval and complying with the governance and compliance controls. Multi-part upload improve on performance. So in general, when your object size reaches 100, you should consider using multi-part upload. The benefit of this is the speed and throughput, interruption recovery, and management of data. So if you have a challenge in your internet connection, it's good to make use of multi-part upload. And also remember the data size of objects we stored in S3, I think the last time we checked was about 5 GB. So if it's more than that, you can make use of multi-part upload, where you upload it in parts and then afterwards you go there and reconstruct your data. Security options, IAM policy, bucket policy, access control list, lifecycle policy, multi-factor authentication, delete. So this is whereby someone wants to delete objects needs to be prompted for an MFA code and versioning. And for MFA delete, versioning needs to be enabled. And the last time I checked, the one that who can enable MFA is the root user in the account. So standard user, no matter how permission you have, you cannot enable multi-factor authentication. So the root user need to go to the CLI and paste, run a command, pasting the code in the authentication device to enroll it. So Snowball, Amazon Snowball use very securely transfer large amount of data. Remember, there's a recommendation if your data is more than 50 GB, you can make use of Snowball family out of AWS by the form of your on-premise data center on Amazon S3 or from S3 back to your data center using Snowball. Snowball device comes in either 50 terabyte or 80 terabyte device, RJ45, SPF or copper, or SPF1 optical. Data copied is encrypted by default via KMS keys and is HIPAA compliant. So connection can be able, you can use RJ45. This is the network adapter cable that you normally use for your router. Also SPF1 copper, and then SPF plus optical. Storage gateways, I think we did for hybrid storage solutions. So when you have your on-premise and you need to maintain a hybrid storage solution, you can use a file gateway, volume, and tape. Protocol used in file NFS SMB. NFS is for Linux-based, SMB is for Windows-based. For volume gateway, you can use SCSI, and for tape gateway, you can use SCSI VTL. And of course, data is encrypted to and from the tape. Remember also, volume gateway offer two flavors. That is cached volume and stored volumes. AWS storage gateway on-premise, still an expansion of it, how it can be done. Can use the F-cycle rules to migrate data after being migrated from the bucket. Two, storage class that has a lower cost. The storage gateway itself is a software appliance. Just a minute, I received. Okay, someone was calling, but it's okay. The storage gateway itself is a software appliance that can be installed within your own data center, and the software appliance that is can be downloaded as a virtual machine and installed on one of your local hosts. So the option, as I say, you have file, volume, and tape. Protocol NFS SMB for file. Volume has offer flavors as cached volume and also a stored volume. Also, Tapeway uses SCSI VTL. For volume, uses SCSI protocol. File gateway, S3 predicted NFS share. Send stored volume uses SCSI devices that are copied asynchronously. Can cover up to 16 terabytes. So for that two volume, 13 times 16, you'll have 512 terabytes. Data is sent to S3 uses SSL connection, and this is encrypted using SSE S3. Cache volume, gateway, volume are presented as SCSI. All data sent to the S3 uses SSL connection and is encrypted using SSE S3. Volume size can be 32 terabyte in size, which makes a total of 1024 for cache volume. Tape gateway, this is virtual tape library. Data is stored in S3, and application and backup software can be mounted on the tape drive in the SCSI devices. When virtual tapes are archived, the data is moved from S3 to Amazon Glacier. Remember, this is for archiving, and like the previous one, for hot data, this is cold data. And I think I'm done with the presentation. Any questions, any clarifications?
Think nothing. I'm seeing that beautiful picture of the community day.
Yeah.
Must have
Yeah,
been
you
an
were there
event.
with you were at the event?
No, I'm saying it must have been a great day.
Yeah, indeed it was. We were with the VP and the CTO of Amazon. Warner, Dr. Warner, and then was in the house. So Terence, I think I'm done.
Terence, over to you, just to, for the closing remarks.
Okay, I think we are still very much in the, what would I call it, the theoretical side of things. There will not be a lot of hands-on, but next week we do the knowledge check. Isn't that so, Mr.? Next week's class will be very brief, but we'll try to do aspects of knowledge check for this particular module, and maybe pre-knowledge check for architecture.
Architecture. All right.
Yeah, so next week, but one, we'll try to do architecture one, at least architecture one, if not architecture two. And we'll see how it goes. But architecture is big.
Yep.
Yeah, so, and it starts here with high availability. So bleeds, I mean, so far, not so bad. I think we can stop there for today, yeah?
Right.
Now, not Albert, Isaac,
Yes.
these people, how many of them were able to finish with the CCP in your group, that is?
I think for the guys who got the vouchers 13, I think something like 5 are remaining. 8 have done.
Okay, but your people don't attend class. They don't want to do CSN.
I think they just have
Anyway,
like,
we make a recording, so they'll always make use of the recording. Huh?
sure.
Okay, so if there's no any other issue, over to you, Isaac. You can wind us up, and we call it a weekend.
Right, just a vote of thanks to Major for sparing his time to share with us his bit of knowledge. We don't take that for granted, and thank you so much. And Terence, also you for your continued support. Thanks a lot. Yeah, so let's look forward to next week on that knowledge check on availability and the knowledge check on architecture, and see how we progress.
Now, Isaac, I have a suggestion. Huh?
Yep.
Is it possible you and I meet the Tanzanians, and is it possible you invite those who want to come into the CSA class from there, even if they're getting it midway?
All right, we can have a chat after here and see how we can get about that.
Yeah, they can be invited because they should also be doing similar things in their own country as soon as they set up.
Sure.
Okay. Okay. I think you have a restful weekend. We see you when you see us. Huh?
All right. Goodbye to all.
Bye-bye.
Bye-bye.